All right, the factoring continues. What is this? It's not a trinomial, so decomposition is not relevant here. But it is a difference of squares because it has a minus in the middle. This has a nice square root, and this has a nice square root. So the way you factor it is two sets of brackets, one with a plus, one with a minus. The square root of 9x squared is 3x. That goes in the first spots. And the square root of 16y squared is 4y. That goes in the second spots. Can't factor that any further, can't factor that any further, so done. This doesn't look like a difference of squares, but if you're thinking difference of squares, you've kind of missed something already. The first thing you should be looking for with any kind of factoring question is, does this have any common factors, and does it ever? This has the common factor. You can take a 3 out of both of these terms. Both of these terms can afford to give up one x, and they can both afford to give up one y. If you do all that, then what remains is 3 divided by 3, nothing. X cubed divided by x. Y divided by y is just gone. And then 27 divided by 3 leaves 9. X divided by x, gone. Y cubed divided by y is y squared. Okay. And now, this is a difference of squares. Again. So we still have our 3xy. And now two sets of brackets to take this, plus, and then minus. The x squared would have come from x times x, and 9y squared would have come from 3y times 3y. There you go. This one is totally impossible if you don't find the common factor first, so watch for those, please. Now these two numbers have square roots, but if you remember the advice from 10 seconds ago, you should be looking for common factors first, and both of these numbers are divisible by 4, so that's the very first thing you should be worried about. 4 comes out and leaves you with 36 p squared q squared minus r squared. And now, this is a difference of squares. So, two sets of brackets, plus, minus. The square root of 36p squared q squared is 6pq. The square root of r squared is r times r. And there you go, all done. So watch for those common factors. We may not always have them in our examples, but they should always be the first thing you think of when you're given something to factor.